This video begins a series of videos on transformations of graphs and sketching graphs. So the first one that we're going to look at is what happens when we place a number in front of a sine or a cosine. So before we can do that, we want to talk about the generic sine and cosine graph. So if you first were to start drawing out values of the sine, so for instance, if we take some x values and then we look at y equals the sine of x, right? So we know when x is 0, the sine of 0 is 0. When x is pi over 6, the sine is 1/2. When x is pi over 4, the sine is root 2 over 2. When x is pi over 3, the sine is root 3 over 2. And when x is pi over 2, the sine is 1. So that takes us through the first quadrant, and then we keep going. So rather than plot the points like we have been doing on the unit circle, what we're now actually going to think about is we're going to think of the x-axis as the x-axis, and it's going to represent our angles. And the y-axis is going to represent the sine of x. So if you're talking about 0, 0, we'd have a point here at 0. If we think of this out here as pi over 2, and we have some values kind of in between that. So halfway through here is pi over 4, and then pi over 6, and pi over 3 are kind of close to pi over 4. So if we plot these points, right, and let's say here is 1. So we'd have pi over 6, 1/2, so about halfway up. We'd have pi over 4, root 2 over 2, so it's going to be a little bit higher here. Pi over 3, root 3 over 2, and I'm just kind of guesstimating where they are based on, you can put them into your calculator and get an actual value for them. And then we have pi over 2, 1. So that first part of our curve begins to look like this. And that is actually what happens with the sine graph. So in terms of looking at the graph of y equals sine x, if we were to kind of keep continuing to do this, the graph itself would actually begin to look like this. And it would go on forever and ever and ever, right? So it would go on in this direction and forever, and it also goes on this way forever. And it repeats itself. My graphing here is not exactly correct in that, it's a little sloppy. But the idea is that the heights here are all the same and the bottoms here are all the same as well. And what they are is 1, and down here is -1. And generally, when we are graphing by hand, we're always interested in looking at what happens to one cycle of the wave. Okay, so on ALEX, when you have to graph, it's going to ask you to put in the points for one cycle of the wave, and then it'll draw the rest of the wave. And when I ask you to draw by hand, you're going to need to label the points for one cycle of the wave. And there are some points that we really care about. So I think of it as when I'm going to graph, there are 5 key points that I'm going to see what happens to these 5 key points. And so this point here is 0, and it's 0 high. This is pi over 2, and it's 1 high. This is pi, and we're back to 0. This is 3 pi over 2, and out here we're at 2 pi. So those 5 points, we're going to be interested in what happens with those 5 points in terms of the sine. And then I'm going to erase a little bit here so I have some room. And then if we're talking about y equals cosine of x, the cosine of x actually graph looks a lot like the sine of x graph, except it starts up here and does a similar thing. And again, we're going to look at one cycle of the wave. So we have to keep going until we get back to kind of where we started. And again, there's 5 key points. So this point here is still, so we're still up here at 1. This is -1, so we're at 0. This point here is at pi over 2. This low point here is at pi. This is at 3 pi over 2. And this here is at 2 pi. So those are the, oops, and I didn't fill in this point here. So those are the 5 key points that we are going to look at when we're dealing with doing transformations to sines and cosine graphs, which is what the next couple videos are going to be about. So, when we look at things like, so y equals a sine x, or y equals a cosine x, this a part, it refers to the scaling for the amplitude. So it's the amplitude. And what the amplitude does, so the amplitude talks about how high or low the graph goes. So in my prior example, right, the sine graph, it went between 1 and -1. And the cosine graph did the same thing, right? So that was the cosine graph between 1 and -1. This part here, how high and low the graph goes, that's talking about the amplitude. So, whoops. So the amplitude is a vertical scaling factor. And it tells us how tall the wave is. The value, how tall the wave is, so the amplitude itself comes from the absolute value of A. So we'll talk about what happens if A is negative in a minute. But how tall we get depends on what the absolute value of A is. So for example, if we wanted to sketch the graph y equals 3 sine x, what that is saying is that before, our amplitude here used to be 1. We went up 1 and down 1. So now there's a 3 here, so we're going to go up 3 and we're going to go down 3. So when I go to sketch this graph, right, I have those original points. So this is kind of my original curve here. Oops, and let me move it down a little bit. I'll erase that part there. So here we are at 1, and this is 0. This point here is 2 pi. Halfway through is pi. Another halfway through is pi over 2, and 3 pi over 2. So our original points were these points here. Right, those are the ones we identified on the last graph. And so now I want to draw a graph where the amplitude is higher. And so, whoops. This point here used to be -1, so now we're going to go -2, -3. Okay, so rather than our graph going from between -1 and 1, it's going to go between 3 and -3. So this point here, the point here at pi over 2, it's now going to move all the way up here. The zeros are going to stay where they are, but this point here that was at -1 is now going to move all the way down here. So our graph is going to look like that. So these 3 points that were on the axis, they're going to stay there, but now we're just going to stretch that graph out between 3 and -3. So another example, if we looked at y equals 1/2 the cosine of x. So if we took the original cosine graph, draw it a little bigger this time. So remember, this was at 1. This was pi over 2. Here we were at pi, and that was down here at minus 1. Here we are at 3 pi over 2, and then finally we were at 2 pi. And the idea is that instead of being between 1 and minus 1, we're now going to shift this to be between 1/2 and minus 1/2, because this number here is a half. So this point is going to start there. This one's still going to stay locked there. We have the minus 1/2 point. Then this one's locked there, and then this one is also at that 1/2. So we're talking about, we kind of just squished our function down a little bit there. If a is negative, so if a is negative in y equals a sine x or y equals a cosine x, then that is going to reflect over the y-axis. So reflect over the y-axis. So for example, if you had y equals negative 2 cosine x. So remember, so generally what I do is I kind of draw my wave. So remember, my original wave would look like this, right? That's the original cosine wave. And so what I'm going to do is I'm going to flip that cosine wave over. So it's going to now look like this orange wave flipped over. And so that takes care of the flipping over, takes care of the negative part, and then I want it to be a 2, which means this high point here is going to be a 2, and this low point here is going to be a minus 2. And then I just need to label these 5 points, right? So I'm always interested in making sure these 5 points are labeled. So out here we're at 2 pi. Halfway through here is pi. Remember, this point here is pi over 4, and this point here is 3 pi over, oops, not pi over 4, pi over 2. Pi over 2, and this point is 3 pi over 2. So it just flips it over. Same thing if you had y equals negative 1/4 sine x, right? So we're going to start with that original sine function, but this time we're going to flip it over. So it's going to look like this. And then, rather than before, these points here, the high and the low point used to be 1 and minus 1, this time that high and the low point is going to be 1/4 and minus 1/4. And then again, we need to label those 5 key points. So 2 pi, this is 3 pi over 2, this is pi over 2. So that's how we're going to get those points there.